Got another exam question walkthrough for the Titrations playlist. So we're at number 13 now. Hope you like the video. I hope you find it helpful. And if you haven't already subscribed to the channel, I would love you to do so. But as always, the link to the questions in the description of the video if you want to try it first. Okay, so make a start. So the question's all about this experiment to determine the solubility of strontium hydroxide in water at 20 degrees C. So we've got all this information to process, and then we've got 3 suggest questions to have a look at before we get into the actual calculation. So the first question suggests why the solution is kept until no more solid needs to be added. Well, if you think about the whole purpose of the experiment, we want to find the maximum amount of strontium hydroxide that's been dissolved into the water. So we want to make sure that the solution is saturated, or the maximum amount of solid has actually been dissolved. Number 2 suggests why it's important to remove the undissolved strontium hydroxide before the titration. Well, if you've got 2 sources of strontium hydroxide, aqueous and solid, they can both react with the hydrochloric acid in the titration. Obviously, we're only interested in the aqueous, the dissolved strontium hydroxide. Any solid there would affect the result. It would actually raise the titer. Moving on to number 3, after the filtration, the solution is stored in a stoppered flask. Suggest a reason for stopping the flask. Well, the obvious thing to go for is to stop it from evaporating. You could have also said something like to prevent it from reacting with carbon dioxide in the air. Moving on to number 4, so which diagram identifies the pipette that is correctly filled? Obviously it's C, because the base of the meniscus is on the graduation line, so C. Moving on to the main part of the question, part 5, we've got some information here that I've highlighted. It's really important, and I'll come back to it in the calculation, but solubility can be quoted as grams of solute per 100 centimeters cubed of solution. And we've got the usual results table, and we've got to do a couple of things before the calculation. We've got to give the equation for the reaction between strontium hydroxide and hydrochloric acid, and we've got to use these results to calculate the mean titer. So starting with the equation, strontium hydroxide reacts with 2 moles of hydrochloric acid to make the salt strontium chloride and 2 moles of H2O. Moving on to the mean titer, well, we never use the rough titer in the mean titer, so get rid of that. We're looking for, out of the 3 accurate titrations, any concordant results. You can see that 1 and 3 are concordant because they're within 0.1 centimeters cubed of each other. Result 2 is a little bit too far away, so we're going to ignore that one. So the mean titer is obviously the mean of those 2 results there. So I'm going to use 32.425 for my calculation. You could also use 32.43. Okay, so the first thing I'm going to do is work out the moles of hydrochloric acid in that mean titer. So that's just concentration times the volume in decimeters cubed. So that's coming out at 3.2425 times 10 to the minus 3 moles. Next thing I'm going to do is apply the mole ratio. So we're going to divide by 2 to get the moles of strontium hydroxide in the 25 cm cubed used in the titration. So that comes out at 1.62125 times 10 to the minus 3 moles. Next part of the calculation is where the units of the solubility kick in. So we know the moles in 25 cm cubed. We want to scale up to 100 centimeters cubed. So we just multiply these moles by 4. So there's that many moles in 100 centimeters cubed. Next thing we do is convert the moles to grams. So the mass of strontium hydroxide in 100 cm cubed is the moles times the MR of strontium hydroxide, which gives a solubility of 0.789 grams per 100 centimeters cubed of solution.